So, good afternoon, welcome. Glad you could find us. People often leave things on airplanes when they travel, and I discovered yesterday that I left my voice. So if you can't hear me, let me know. I know there's a microphone here too, so maybe that will help. But I'm assuming you can hear me okay in the back right now, yes? Good, and you're awake. All right. So welcome to our session on collaborative space, is it worth it? Measuring the impact in quantitative terms. My name is Janice Falzo, and I am professor and chair of biology and professor of Latin American and Women's Studies at the University of Scranton. My colleagues today are Leila Kamal, who is vice president for design and expertise of EYP architecture and engineering and is an architect. And our other architect is Kip Ellis, who is academic planning and design principal of EYP and who has worked on projects at Swarthmore, Franklin and Marshall, Ohio State University, and the University of Scranton, which is how we got to know each other. Today, we want to share with you some case studies that demonstrate how spaces influence formal and informal teaching and learning activities. Kip will introduce you to 5 scales of informal learning spaces. I will share my firsthand experience with the University of Scranton's Loyola Science Center, an EYP project that was just completed this past fall. Leila will provide quantitative data from EYP's ongoing assessment of existing, renovated, and new spaces. And we plan to have plenty of time for discussion afterward. So Kip, please go ahead.
Thank you. So in our experience, we thought it might be helpful to go back and look at the portfolio of projects that we've designed over a decade's worth of work for higher education, particularly those centers for science education and research, but what we commonly call the lingo STEM facilities. And we really wanted to survey a range of projects to evaluate the changes that have occurred, both on the part of our institutional interest in the types and allocation of informal learning spaces. Do we see any trends in terms of what's changed over a decade? And also to evaluate the relative distribution of different scales and types of spaces. So the first part of data we'll present is just a little summary of our findings on the different types. You can see the names of the institution on the screen. They range from private liberal arts colleges to publicly funded colleges and universities. They are a combination of renovation projects, renovation with new construction, or all new construction. So we see a variety of different project types and client types. But from an analysis standpoint, we were looking for some common threads in terms of the interest to budget construction or renovation dollars toward different types of informal learning spaces. Also, for those of you who may or may not be familiar, typically a STEM facility will involve teaching spaces of different types, what many people call instructional laboratories. There is often, usually, a component of faculty and student research. There's often instrumentation and support spaces that allow those laboratories to be utilized. Of course, you need faculty offices and other types of instructional spaces we'll call classrooms. But today we're really going to focus on informal learning spaces that we like to think of as the glue that holds all these program components together. And collectively, these spaces form a continuum of science education. There are 5 scales, we believe, based on our experience. Large-scale spaces we like to think of as a commons or common area where large groups of students or faculty can gather. They frequently work as a living room type space for projects. Here's a shot of the Science Commons at Swarthmore College. In tracking our data and looking at projects over a decade's worth of design, on the bottom, on the y-axis, you'll see, the x-axis, you'll see Swarthmore and Hamilton College, which were in design a decade ago, and more recently, Trinity and the University of Scranton on the right-hand side. The scale on the y-axis will indicate the total net square foot areas that were allocated for these types of spaces. So when we actually look at all of these clients' interest in creating a commons, we see a variety of amounts of area. Now, part of that is just the fact that the projects are a different scale. But interestingly, what we have seen was very few exceptions. Everyone is interested in creating some of these types of spaces. Overall, we can see an average of a little over 20% of the net area in project construction actually went for these commons or living room spaces collectively on average in those projects. The second scale space is student study space. This is often where groups of 2 to say 6 students will meet to work on homework and projects. Here's a shot from an early one we did at Hamilton College. Often these spaces are adjacent or near to commons areas like this shot at the College of the Holy Cross. What we've seen interestingly in the data for this is that the area that is allocated for this has gone nowhere but up over a decade, because every time a building was completed, faculty would go see projects and hear that students love them, and there are never enough in the building. So definitely a marked increase in a decade's worth of practice. And on average right now, of the informal spaces, about 34% has been allocated for that scale. A third type is called departmental or discipline lounges. These are spaces that are dedicated for larger groups of students, let's say somewhere between 10 to 30 that get together for academic clubs. At Hamilton College, it was a big concern to make sure to have those spaces so that individual disciplines or departments wouldn't lose their identity for their majors. And in fact, we created those types of spaces at junctures in circulation and highly visible locations. In more contemporary times, what we found is there's been a renewed interest in creating lounges, not necessarily to promote department or discipline-specific places in a certain location, but to create shared opportunities for different academic clubs to use those spaces in different ways. And so we're creating slightly more flexible, less department or discipline-specific space. What's interesting is we sort of see almost an inverse bell curve, I guess, here. In the early days, a decade ago, everyone was really worried about discipline identity. Then, about 5 or 6 years ago, people weren't as concerned. Now they're actually concerned about making sure they do have that kind of multi-purpose space for their students. So it's an interesting change over a decade, but what we really see is, on average now, about 9% of informal spaces there. The next scale we like to call kind of faculty-student interaction space. Here's a shot, as the economics of building mean that faculty offices have to be smaller than they may be in some older buildings. We found that creating areas for faculty and students to get together, we call it breakout space, frequently in the vicinity of offices, really provides an excellent opportunity for impromptu discussion and for groups of students or groups of faculty to get around a table or do chalk talk where you couldn't accommodate that many in an office. Not surprising, the interest in this type of space has definitely skyrocketed over a decade, and on average, over a decade's worth of work, we've seen that average about 19% of the informal areas. The next scale I'd like to talk about is write-up space for faculty-student research. This is a shot of Hamilton College's research space, again designed over a decade ago, but showing what I would call the prototypical undergraduate science research space with write-up near the window and then benches for activity and board. In fact, over time, everyone's been talking about how do you really increase collaboration. Well, one way you can do it is actually by having groups of faculty and the students that are mentored by faculty get together in space. About 6 years ago, when we were planning the Barsinger Life Science and Philosophy building at F&M, we began to experiment with combining these write-up areas in the middle between 2 faculty investigatory laboratories. And of course, that model was very popular for quite a while. It really isolated write-up and breakout space from the wet research areas. Here you see an example of that pattern we used at New York University. In more recent times, however, there's been a real move to promote collaborative use of space among faculty. So at the College of the Holy Cross in this plan, the research laboratories are in blue and write-up is in orange. And by co-linking these lab spaces together, it increases flexibility. And by clustering the orange spaces so that they are shared between laboratories, it really helps to create a culture among the students that enhances collaboration. Overall, just to reflect on what we've learned, is that the proportion of write-up space for these buildings has exploded because people began to largely abandon the idea of an isolated cell for faculty research space and instead are interested in collaborative research. So we see a marked change almost overnight that started about 6 years ago. Overall, we found that the interest and percentage of this is about 18% of the informal areas of the building. So if we look at the cumulative analysis, what that tells us is the white bars represent the net areas that were programmed for all of these projects. Here you see in orange the amount of space in those buildings that's used for informal learning. And over that decade, the average was about 8,500 net square feet. In relative percentages, it's averaged almost 11%. In fact, what we have found is that in projects on the boards now, that percentage has moved to the 12 to 15% range. There's one other really important point, and this is my last one, is the rise of transparency as an important part of the design for collaboration. The projects that we showed you from earlier in the decade, Swarthmore and Hamilton, had key areas where the faculty were interested in using more glass to promote visibility of the science and connection. In fact, over the last decade, the interest in openness has also exploded. These are shots of Trinity University. Here's the College of the Holy Cross. The importance of making science buildings welcoming, that's inviting to all students, both majors and non-majors, is a crucial part of enhancing collaboration. The spaces inside, you want welcoming, light-filled spaces where students can get together and do a variety of things. Visibility of the sciences, these are instructional teaching laboratories at the University of Scranton. Walls of glass, as you walk through the corridors, you see what's going on in those learning environments. Classrooms, walls of glass in classrooms that students can write on, not only just at the whiteboard, but at the glass wall on your right, which is actually a wall between the classroom and the corridor. Vistas into research laboratories and write-up. These are all crucial because they have in fact opened up the dark, light blocking and visibility blocking walls that everyone had often associated with science. Even creating spaces for students to do their study. Here's one. Glassed in, provides some acoustic privacy for students along the corridor. And with that, I'll turn it over to Janice and she'll talk a little bit more about what happened at Scranton.
Thank you. I want to begin by describing for you some of the challenges of what we had faced in our old building. So in the large frame, you'll see our former Loyola Hall of Science. And I like to think about all the problems that we had in terms of atmosphere, both literally and figuratively. So literally, you can see window air conditioning. There was no central air conditioning. We had students passing out in introductory laboratories the first week because it was hot and it wasn't cool enough in the building. The heating was unequal across the building. And there were serious problems with ventilation where the fumes from the organic lab on the 4th floor would go through the drainage system and come up through the sinks on the 1st floor. We had retrofitted labs, so this is a comparative anatomy lab, and we had these vents on the desktop, on the bench top, to pull some of the fumes from this, the specimens as the students dissected them. But of course, then that meant that it took away bench space and also meant that it took away the clear vision that the faculty member would have to see what was going on in the room. Figuratively, though, the atmosphere, I think, was even more important. We have really shiny floors at the University of Scranton, but you can see this was a long hallway with often shut doors. There was no place for students to wait while they were waiting to see a faculty member. There were no places for students to gather or to gather with faculty. And it gave the impression that science was something that goes on in small, sequestered spaces where no one can see you, and that science is a solitary kind of work. Research spaces were mostly in retrofitted classrooms. So this is our SEM, and it's in what was originally a classroom. There were windows, but of course you can't have lights, so we had black paper on the windows. Lots of wiring everywhere to provide enough power for some of these pieces of equipment. And then finally, although our faculty are very accessible to our students, we had no place to meet in groups. So this was my old office. And one of the things that also had struck me when I first went to Scranton to interview is that I wondered why everybody had their shades closed. And then when I went and started working there, I realized that it was because you can't open them. The shades were built in between the panes of glass. And so all you could do is make them horizontal. You could never raise them. So even though I had windows in my office, I could never have as much light and vision as I wish I had. So what did we hope for? Well, all the way back in the spring of 1999, so that's well over 10 years ago, because our building opened in fall of 2012, the Dean of the College of Arts and Sciences appointed a committee of faculty from all of the STEM disciplines, science, technology, engineering, and mathematics, first charged to look at science education, but we soon moved to looking at our facilities and the ways that we would like to use them to enhance our programs. By the following fall, we were earnestly working on plans for a new science facility that, in our words, would address the fundamentals for natural science education in the 21st century. We developed a vision statement, and part of that earliest expression of our vision is as follows. Education that occurs outside the classroom can be just as effective, if not more effective, than education in the classroom. We wish to create a natural science community that educates all who walk into the building and through the hallways. The availability of lounge areas, informal study areas, and pleasant surroundings will create an atmosphere where students and faculty will want to gather. We believe that through these common areas, students may be more likely to engage in conversation with faculty, and faculty will have greater opportunity to learn more about each other's interests. We believe that by creating this natural science community, we will be contributing greatly to the creation of a culture of science on our campus. So several groups of faculty and administrators attended PCAL meetings. Thank you, Jeannie. She's there. Hey, Jeannie. And visited other new buildings. And from those workshops and our committee meetings, we gained a clearer view of our project, so that when we came to really deciding what we wanted, we said, science is an exciting, creative, interactive family of disciplines. It's as human as history, philosophy, or the social sciences. We seek a science center that will highlight the human, interactive nature of science. It's amazing to me now to look back at our original concept paper and appreciate how true to that vision this project has stayed. So this is a view of a stairway that connects 2 floors in our new building. You can see several of the different kinds of spaces that Kip was mentioning, and I'm going to talk more about those spaces in a minute. So we have lounge areas, we have informal study areas, and we have spaces where we do gather, faculty and students. We wanted to have science on display. This is the main hallway of our building with display cases. It's a gathering space, and off of this hallway are laboratories with windows so students, anyone walking through the building, can see what's going on in those labs, and we have lots and lots of collaborative learning spaces. So our project incorporated the 5 scales of spaces that Kip just described, and I'd like to share with you examples of how those spaces are being used in our building. First of all, our building now has an entrance. So this is renovated space. This is all new construction. This entrance is on the main corridor of our campus. And so what it did by putting the entrance here is it put science right in the center of our campus. The entrance now is very transparent. It's very welcoming. It's a very active site. And it has also blended in with the adjacent non-renovated part of this building, and the transparency certainly comes through. Once you enter that space, there is a long public walkway with those display cases that I showed you. There are aquaria right here, which I'll show you in a minute. So along this main corridor, there's a very open and public sense of the building. Then we have 3 sections of new space, which joined by an elbow, as we call it. This elbow includes teaching spaces and administrative spaces. And then there are 3 sections of research, teaching, and research labs on each floor. So here's that main walkway when you come in, and it looks something like this. The front door is actually at the back of this photo, and you're coming in. This is the adjacent introductory biology lab, and now they write on each week what's going on the glass so that anybody walking by knows what the topic is of the lab, or they'll put diagrams of the organism so that anyone coming through here will know a little bit about what's going on. Then, as I said, the rest of the building has these other three blocks and the elbow. So the first scale of space that Kip mentioned are the commons, and we have several large spaces. One is that walkway, and another is this large atrium that's again glass fill. It's visible through 3 stories actually, because there's this is the the first floor, a second floor, and then the 3rd floor looks out at it. And adjacent to this is a coffee shop, sandwich shop. So this space is always populated by people talking, groups of students working, and also by people eating and drinking coffee. Part of our message in this is that this building belongs to everyone on our campus. Every student is required to take at least 2 natural history, science, math courses. And so this building is used by every single student on that campus, and we wanted every student to feel ownership of that building, and the faculty as well. In fact, we now have our faculty dining room in our science building. The next level is student spaces, and we really stuck our neck out on this. Every single corner, so every vertical column of each of those main blocks of our building and the back corners, every single level has a student study space. They look like this here. They're enclosed by glass with a door so that they are separated from noise going on, and yet students can see who's in there, they can see their friends. There's wireless throughout the building, obviously. There's floor-to-ceiling blackboards, but they're also free to use the glass, and they do. And so walking through the building on any given day, you might see the Krebs cycle, you might see a diagram of phylogenies of animals, you might see mathematical equations, and they really are writing all over these spaces. These spaces were occupied from the day the building opened. It was as if they were just waiting to run in. And last semester was our first final exam period in which we completely occupied the building. And it was amazing. It was the best final exam period I've ever had, I've ever experienced. The whole building was abuzz with students learning, and they were working together in groups, they were teaching each other, they wanted more space. Every single corner of these spaces that we provided have been occupied continuously by our students. The next scale are these departmental or interdisciplinary lounges. This lounge is for the computer science department, and you can see that there are tables where there are several computers set together. Students can either gather around, the chairs are on wheels. Students can work collaboratively on one computer or each work on different computers, but as a group. Again, the students are writing all over the glass and throughout the building. And there's also some resources. Remember books, right? There's some of those there too. Next, we have faculty-student breakout spaces. And those spaces, on each floor, there is a suite of 5 faculty offices. And then there is these joint faculty-student breakout spaces immediately adjacent to them. This was especially important to us because as we began planning our building, we kept emphasizing that we wanted to be as accessible to our students as we possibly could. We didn't want to be back in some faculty ghetto at the end of a long, dark hallway. And so what these spaces do for the faculty is that while it makes us visible and we can leave our doors open, so here's one of these spaces. These are faculty offices. There's a group of 5 of them. But then there is this space that students walking by, this is the main hallway outside the building, they can see that we're in, they can see that our office is open, but we don't have the noise from the hallway. And we can leave these doors open if we want to, that come in here. It also let us be able to open our windows in our offices if we wanted to. So we have HVAC separation in these spaces. These spaces, this is an early photo, these spaces now have tables and chairs where we can meet with several students at a time. Faculty also use these spaces to give makeup exams. Sometimes groups of students are working there together. Students can wait for faculty. We put journals out, we can put specimens out, we can put things that we think students might be interested in, and it catches their eye and brings them in and brings them into our offices, which was what we really, really wanted. And finally, we have write-up spaces. So one of our goals in our building was to help our students understand the collaborative nature of science. And so we made an intentional decision not to have individual research labs, and instead to have clustered labs so that we would be more like a modern research institution, so that our students would have the sense of that current model of collaborative interdisciplinary research. So each of these spaces contains the laboratory space for 5 faculty, and then outside of each of those spaces is a student write-up space, specifically for the students who are involved in working in research in that lab. So this is what one of those spaces looks like. And again, the students have completely populated these areas. They have card swipe access so they can get into them anytime they want to. And some of them live there. We've put in some of them, we have little lounges where they have microwaves, they have sofas, they have little kitchenettes. There are lots of table space there. There's lots of power. There's lots of internet connections if they want it. And faculty use these spaces as lab meeting spaces. Students use them to work on projects in the lab. They can also work on homework if they're doing research in the lab and they need to keep running back and forth and do something and then come back. They can work there. And we wanted to get this, again, the culture of science, that science is an active, interdisciplinary, and also collaborative kind of activity. So those have also been used wonderfully. I wanted to just say a word also about the influence of transparency on our teaching. Kit mentioned transparency, and I've been especially impressed on how positive an influence that transparency has been. So this room is a math library on our main hallway. It's one of the first rooms that you come into the main building. And I teach general biology, among other things, and one of the first activities we do in my class is that students need to build a giant cell. We build the cell to a scale model of the cell using found materials, and the students need to make it large enough, it's 30 centimeters to a micrometer, and different groups of students are responsible for building each particular organelle and then teaching the rest of the class about that organelle. So the math department is friendly. I asked them if we could use the space. We took it over for a week. We completely filled it with all the components of the cell, labeled things, and then after we did that, then I co-opted the hallway and it became my classroom for that day because the students were teaching each other about all of the components of the cell. And it was the transparency that permitted us to do that. Last year I taught invertebrate biology, and that year our humanities faculty were occupying the offices that we eventually had. So we had a science building filled with humanists, which was wonderful. And there was a cluster of philosophers across the hallway from where I was teaching invertebrates, and every week I would have amazing, beautiful snails and sponges and sea urchins, and I wanted them to see these things. And so as they would walk by, rather than pretending I didn't see them, I would open the door and pull them in and make them look at them. And it was beautiful, and it was great for them to see. I also put a tree of life on the glass window of the room, and then each week as we added a new phylum, I would add another branch to that tree of life so they would know what we were doing. I also, because I'm chair, need to observe faculty. And this is one of the rooms that I had to observe a faculty member in, not this particular one. And because there's another aspect of transparency, and that is transparency within the room. You remember the image I showed you of our comparative anatomy lab with the vents. Well, these are snorkels that can be pulled down to provide ventilation for individual students with lamps, which was EYP's idea to put the lights on them. And when we don't use them, we can push them out of the way. I went in to evaluate a faculty member who was teaching comparative anatomy, and he had his specimen here. There are document cameras embedded in the ceiling, but they were using them to project the dissection. Then there were students who were using their cell phones to videotape the faculty member, which was great. I mean, they were all doing whatever they needed to do to learn. I have also used this space for a hybrid or studio course that I teach on comparative biomechanics. And I can use this space as lecture, discussion, wet lab, dry lab, computer lab. Because of the configuration of the nice flat open benches, computers along the outside, plenty of sinks, we can do all of those things in one space. There's an adjacent breakout room so students can have their coffee or their snack or something. If we need to have a discussion and we want to leave things going in this room, we can go into that open space next door. And it's really changed the way we've been able to teach our courses. So our new building is an amazing contrast to our former home. We have state-of-the-art classrooms, teaching laboratories, research spaces, faculty offices, and informal gathering spaces that reflect the interactive nature of science and encourage active participation. These spaces have already begun to transform how we envision our courses and how our students learn. I've been especially impressed with the rapid transition our students have undergone to a strong culture of science and the sense of community as STEM students. Layla will now share some of her research on these types of transformations.
Thank you, Janice. How are we doing? Is it still, I know it's dark and kind of dreary in here. I'm gonna probably talk a little bit fast because I want to try and make sure that we have time at the end if you have any questions. But I want to start by saying that there is obviously a tremendous amount of anecdotal evidence right now that suggests that STEM buildings that are designed and built with the types of spaces that Kip and Janice are talking about are having a really big impact. These renovated and sometimes new buildings are becoming the destination of choice on campuses, and students and faculty are spending more time in these buildings than they ever have before. And it also appears that these new facilities are attracting more students ultimately into the sciences, which is really important. So all this anecdotal evidence, a couple years ago, I became really intrigued with this idea about how we could find a way to measure the outcome of new STEM buildings in some scientific way. So really looking at how to gather some empirical data that would help institutions justify what turns out to be sometimes an enormous investment to improve their science facilities. So as you may have heard, we at EYP are a bunch of architects and engineers, and we knew that in order to do this research and to do it properly, we really needed to team up with someone who was a social scientist. And so we did team up with Royce Singleton, who is co-author of this book, Approaches to Social Research, and Professor Emeritus at the College of Holy Cross. And he helped us write all of our research methodologies and ultimately our tools for survey, which became a really important component in terms of gathering the data. So I'm going to share with you some of our research data, comparing two colleges. The first we will call College X. It's really the College of Holy Cross. We're calling it College X because the idea is that they could be essentially any institution that was recently renovated. So their story is very similar to the one that you heard Janice just tell you about. Their tales of woe. Their building was too hot, their building was too cold, the roof was leaking, they felt that they didn't have enough space to do the things they needed to do, accessibility and therefore code issues were coming into play. And for whatever reason, people felt that biology space was better than everybody else's in the building, and the roof was still leaking. And there was just an incredible amount of frustration. Well, that facility has since been changed into this. You can see the entrance there on the left, the new entrance to the facility, and that is that exact same atrium space redesigned and rebuilt in situ there on the right with all those wonderful breakout spaces and collaborative spaces that Kip and Janice have been talking about. So this will be our after case. Our before case is at Trinity University in Texas. This is their Moody Science Building, and you can see the entrance to their building there on the left, which is lovely. And so we felt, and this obviously they're making the investment as we speak to improve their science facilities at Trinity, but we thought this would be a really good before case scenario, so we went ahead and gathered data before the building was finished with design and certainly before construction was completed to compare the two institutions and more specifically the two facilities. And these are images inside Trinity Moody Science Building. This is on the left is a typical research lab, on the right is a typical chemistry teaching lab. So I'm going to show you lots of charts and graphs. If you can't see the data from the back, don't worry, I'll describe to you what the charts say. So one of the first things we really wanted to understand was why science majors were going to STEM buildings. What was it that was attracting them into these buildings? And you can see the number of students on the left, the number of students surveyed. Along the bottom are the reasons why they're actually going to these STEM buildings. And in every one of these charts, the Trinity before case will be in orange, and College X after case will be in gray. So you can see that the number one reason for both institutions was to go there, obviously, to attend class and then meet with faculty outside of class, which is kind of required when you're in the sciences. After that, something really interesting happens. When you look at the students that are going to these buildings to study and do homework, the difference between the two facilities is huge. At the College of Holy Cross, there's almost 80% of students are going there, are staying in the building after they go to class to study and do homework, compared with barely 40% at the unrenovated before scenario at Trinity. In addition, at College X, students were going there to purchase food and drink in the Science Cafe. And this is a really important theme because we also ask non-science majors why they go to these facilities, which is an important thing to understand when you're trying to draw your campus community into your building. And of course, the number one answer for the non-science majors in College X was they were going there to purchase food and drinks in the Science Cafe. Well, again, something very interesting happens after that because these students stay and they study and they do homework in this facility. The non-science majors are staying in this facility to study and do homework. In fact, 50% of the students surveyed said that they were staying at College X in the after scenario to study and do homework, compared to barely 10% of the students surveyed at Trinity in the before scenario. And interestingly, beyond that, what we learned was that probably, and actually 40% of all students surveyed said, who were non-science majors at Trinity, said they had absolutely no reason to go there at all, unless they were forced to either take a class or to meet with a particular faculty member. So we wanted to drill down into this a little bit more and understand what it was about the features in the spaces that the students were studying in at College X to understand what they felt was really important. And this is a very complex chart. I'll explain it to you. On the left are the features of those study spaces. Across the top is a scale that ranges from left to right, from not at all important to extremely important. And then the highlighted number with the box is that average, and next to that is there's a standard deviation, but we don't need to go into that. So essentially, what we learned from this is that the top three reasons, the top three favorite features was good lighting. They went there and studied there because it was a convenient place to be before and after class, which absolutely goes to what Kip was talking about in terms of strategies about where you place these collaborative spaces within the building. You can't lump them all together or just sort of randomly place them. You really have to think about where they need to go in the building strategically. And then obviously for study, they're looking for a generally quiet place. We also asked them what the important features in making the spaces attractive place to meet with other students, which is different than why you might go to a place to study, particularly on your own. And this chart is set up the same way. The top three answers were the availability of tables and chairs in those spaces, making sure there was comfortable furniture in the public places, and then again, making sure that there was a convenient place for them to meet before and after classes. Those were the top 3 reasons, favorite features, to meet with other students in the building at College X. We also asked the students to rate both Trinity and College X as a place to study. And at Trinity, 35% of the students said it was one of the last places of choice. And by contrast, at College X, over 50% of it said it was one of their favorite places to study. We asked the students to rate both Trinity and College X facilities as a place to meet with others, again, slightly different than going there to study. And at Trinity University, almost 60% said it was either acceptable or one of their last places of choice, compared to College X, where 90% of the students said it was good or one of their favorite places to meet with others. We asked the students at both institutions whether they thought their STEM facilities were comfortable places to work. At Trinity, over 60% of the students disagreed or were kind of ambivalent. And at College X, almost 90% agreed or strongly agreed with that statement. We also asked the faculty whether they thought it was a comfortable place to work. So we asked them the same question, and at Trinity, 75% of the faculty survey either disagreed or strongly disagreed with that statement. And at College X, the after scenario, they agreed or strongly agreed with that statement. And you can see on the chart the difference between the 2 facilities and the reaction to that statement. We also wanted to understand, before we started design at Trinity University, what were some student suggestions for improving the situation at Trinity University. And interestingly, you see at the bottom of the chart, again, the reasons along the left, and then the responses, the percentage of students in the middle column I'm focused on. Interestingly, there was about 22% who weren't quite sure what needed to be done to actually improve the place. And there were a lot of random and varied suggestions that would absolutely have helped to improve the place, but they were pretty random. But nevertheless, about 19%, just under 19% of students said, it'd be really helpful if you could add more common and study areas. In the Moody building at Trinity, they had 1. And that room was actually a pretty small room that fit probably 15 to 20 students and was used mostly as a computer lab. 13% said, it would be great if you could improve the lighting, which is very consistent with what we were hearing in terms of the students at College X tell us these were the really important features to them in the spaces that they like to hang out, either to study or to meet with others. So we asked the students also at College X, after it was completed, what would be the things that you would improve about the STEM facility there? And interestingly, their number 1 response was, more food, please. Keep the cafe open later. And then the next one is even more interesting in some ways because they're asking for more places to work and to study together, which goes back to what Kip was talking about in terms of the trend that we're seeing. The more of these spaces we design, the more they become in demand, and the more we really need to think about where they go in these facilities and how they can actually support the different activities and functions of the student and faculty within. And then the next one is really interesting too because it brings up this whole other notion. 9% of all the students said, could you please keep the facility open later? Which now starts to talk about how, now that we've gotten all these people into the facility, it's like Janice said, they live there, they don't want to go home. How are we going to deal with that in the future? These are good problems to have though. Also, we're switching graphs here for a moment. College X has been open now. This is, again, the College of Holy Cross. Has been open now for over 2 years. And so we wanted to see what, if any, changes had happened regarding the number of applicants. So on this chart, you can see along the bottom, the yellow is the matriculation, the red, hovering right around 2,000 students, is the number of students they accept, and the blue squiggly line at the top is the number of students that apply. And if you look right around this big spike that happens, I think, right around 2005, 2006, happens to coincide with when they announced their new science facility that would be opening, that they were going to renovate and do something about the situation, and then again another spike in 2010 when the facility actually opens. And what's interesting about this is that because the College of Holy Cross is keeping their acceptance and therefore their matriculation at an even level, and the number of students applying is going up, one could potentially deduce that they're allowed to be more selective in that scenario. This graph shows the comparison of biology and chemistry departments at College X. And the biology building, just to remind you, at College X was not renovated, and the chemistry building was. And what this shows us is that there's been a substantial increase in the number of chemistry students doing research in the facility. Again, a really big spike just after the new complex opened. And then finally, we looked at the number of majors graduating from the sciences at College X. Again, you can see a really big spike after the project completion for the chemistry students, from 20 students in chemistry to almost 40 within the 2 years after the facility had been opened. And for anyone that's interested, that's the end of our charts and graphs. I didn't want to kill you with all the charts and graphs. But anyone interested in reading the full reports for the College of Holy Cross and for Trinity University, just leave your business card with your email, and I will send you the link to where you can get access to those reports, and then you can read them at your leisure. And if you have any suggestions for us too in terms of our research, please feel free to make recommendations. If there are things that you feel that we need to be looking at, researching, that would help you in your planning for your science facilities, please let us know.